Hello Year 11s, this is the refinement of your Further Maths Paper 2 additional sample paper, which is calculator. Question 1, work out the values of A and B. The first thing I'm going to do is multiply that first matrix by 3. Gives me 6, negative 15, 3, 0, times by 4, negative 3. Row by column, so 6 times 4 plus 3 times negative 3 gives me 24, take away 9, gives me 15, and then row by column, so negative 15 times 4 plus 0 times negative 3 is negative 60, plus 0 is negative 60. So A must be 15, and B must be negative 60. You would get 1 mark for multiplying the first matrix by 3, or if you've multiplied the second matrix by 3, that's fine, just so long as you haven't multiplied both of them by 3. 1 mark for 15, 60, and then 1 mark for A is 15 and B is 60. B is negative 60. B, work out this. So I'm going to do top row by left column to get my top left element. So that's 5 times 2 plus negative 3 times negative 1, which gives me 10 plus 3, which is 13. And then bottom row by left column to get my bottom left element. 1 times 2 plus 2 times negative 1 is 2 plus negative 2, gives me 0. Top row times right column to get my top right element. 5 times negative 3 plus negative 3 times 5 is negative 15, plus negative 15 is negative 30. And then bottom times right gives me bottom right. 1 times negative 3 plus 2 times 5 gives me negative 3 plus 10 is 7. You would get 1 mark if you had 2 elements correct, 2 marks for all 4 correct. 2a. Write this as a single fraction in its simplest form. I'm going to keep flip change, so 5 over 2m times 3m squared over 10. I'm then going to cross simplify, so I can divide through by 5 here, so this becomes 1, this becomes 2, and I can divide through by m. Get rid of my squared, get rid of that, so I'm going to be left with 1 times 3m is 3m over 2 times 2 is 4. 3m over 4 is my final answer. You would get 1 mark for showing keep flip change, the timesing by the reciprocal. You would get 1 mark for, I'll just show you a few ways you could do it. 1 mark for multiplying through, getting 15m squared over 20m, or any of these. And then 4 marks for 3m over 4 is your final answer. B, write this as a single fraction in its simplest form. I'm adding, so I need a common denominator. My LCM is going to be, well, the LCM of 4 and 6 is 12, so it's going to be 12, and then I'll need the x and the y. 12xy. So I've times this fraction by 3y, so my numerator is 21y, and I've times this fraction by 2x, so my numerator is 10x. Adding them together gives me 21y plus 10x over 12xy. You would get 1 mark for either of these fractions. Full marks for this as your final answer. 3. Work out the positive value of x at which the rate of change of y with respect to x is 81. This means I need to differentiate and then set it equal to 81 and solve to find x. I might get a couple of values, but I'll take the positive one. So differentiating, I get 5x to the 4 plus 1. Now I'm going to set that equal to 81. 5x to the 4 plus 1 equals 81. So 5x to the 4 equals 80. So x to the 4 is 16. The fourth root of 16 is 2 or negative 2, but I take the positive value. So x is equal to 2 is my final answer. You'd get 1 mark for either 5x to the 4 or plus 1. 1 mark for getting as far as x to the 4 is 16. And full marks for 2 as your final answer. Question 4. A, B, C and D are points on a circle. AC and BD intersect at E. Prove this. For prove questions with circle theorems, I need to give reasons. Give reasons. I'm going to start with any angles that I can label. Well, this angle is going to be 2y. I'm going to put a little 1 there and say y. So down here, the reason that's 2y is angles in the same segment are equal. Angles in same segment equal. And I've got another one of those down here, x. I'm going to put a number 2 there. Same thing, angles in the same segment are equal. I also know that this is going to be 2x. The reason is that I'll put a little 3 there. Vertically opposite angles are equal. Vertically opposite angles equal. And I can now see I've got angles in a triangle that sum to 180. So I'm going to say x plus 2x plus 2y equals 180. The reason is angles in a triangle sum to 180. And then I'm going to see if I can simplify this. I can see y is the subject, so I'm going to see if I can make y the subject. So 3x plus 2y equals 180. So 2y is 180 minus 3x. So y is 90 minus 3 over 2x. And I've shown the thing. I can write this, or I can write QED. I don't need to, but I'm feeling fancy to show the thing. Show that I've shown the thing they asked for. You would get 1 mark for either saying this is 2y. A bit slow. 1 mark for saying this is 2y or this is x. You would get 1 mark for forming an equation using your angles in a triangle sum to 180. And full marks for getting up to this with correct algebra and reasons given for each step of your work. You do need to give reasons for this. Question 5. Fx is this. Which value of x cannot be in the domain of f of x? I know that this is often a question they ask when, and it's to do with the denominator being equal to 0. We don't like a denominator of 0, so I don't want 6x minus 5, my denominator to be 0. So 6x is 5, x is 5/6. That's the thing I don't want. That's the thing I can't include, so I'm going to circle this one. 1 mark for that. Part B. Gx is this with domain this. Work out the range of g of x. Give your answer as an inequality. Range I know is everything to do with y, not x. So in this instance, everything to do with gx rather than x. I'm going to do a sketch of this. So it's going from -5 to 2. So I'm going to sub in when x is -5. So 32 minus 3 lots of -5. So 32 plus 15, which gives me 47. And I'm going to sub in when x is 2. 32 minus 3 lots of 2. So 32 minus 6 gives me 26. This is just a nice linear graph, so there's not going to be anything weird going on between these two values. It's not going to like go up and then come back down, or go down and then come back up. I'm just going to do a quick sketch from -5 on x to 2. At -5 I'm at 47, and at 2 I'm at 26. So my graph goes like this. My range is this, and it can be equal to those values. So it's going to be g of x is less than or equal to 26. Sorry, greater than or equal to 26 and less than or equal to 47. You would get 1 mark if you had this, but you hadn't included the, I'll just show you. If you hadn't included the equals sort of little line under either of the sides. You'll get, if you've written x, you'll get 1 mark. It doesn't actually show that you'd get the mark if you wrote y, so you must write the g of x, not y, because there's actually no y anywhere here. Question 6. This F shape is made from rectangles. All lengths are in centimetres. The perimeter of the shape is 64. Show this. Perimeter, so that's the distance round the outside. So I'm going to add up all of my sides. This side I can see has not been labelled, but that's going to be all of my vertical sides added together. So this side is going to be y plus 2x plus y plus 2x. So this is going to be 2y plus 4x for this dimension. Adding up my sides, I'm going to tick them off once I've got them so that I don't double count anything. I'm going to start with the x. I've got x plus 2x plus x plus y plus x plus 2x plus 2x plus y plus 3x plus 2y plus 4x. Collecting my like terms, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Lots of x plus 1, 2, 3, 4 lots of y, and that must be equal to 64. You can see they've made y the subject, so 4y is 64 minus 16x, so y is 16 minus 4x, which is the thing they asked for. You would get 1 mark for forming an expression for the perimeter, and then full marks for rearranging it to land at this. B, the area of the shape is A. Show that A is this. I can see that they've given me the area in terms of just x. So I'm going to find an expression for my area and then use my answer for part A to replace any y's with that thing in terms of x. I'm going to split this into rectangles. It doesn't matter how you split it, I'm going to go for these 3 rectangles. So this rectangle is going to be x times y. This rectangle is going to be 2x times y, the area, and this rectangle is going to be x times 2y plus 4x. Plus 4x. I'm going to write those for part B. So I've got my 2xy plus my xy plus my x times 2y plus 4x. Collect my xy's there. I've got 3xy and expand this. 2xy plus 4x squared gives me 5xy plus 4x squared. I'm going to replace that y, because there's no y in this, I'm going to replace that y with 16 minus 4x, this thing here. 5x lots of 16 minus 4x plus 4x squared gives me 80x minus 20x squared plus 4x squared, which is 80x minus 16x squared, which is the thing they asked me to prove. You would get 1 mark for 4x squared. Getting up to this line. 1 mark for replacing your y with 16 minus 4x, so getting to this line. And then full marks for rearranging to get to this. And would we need the A? I think we should have the A as well. Technically, because it's a show that we want to show that exact thing, so I'm just going to put my A in there to be on the safe side. Okay, question 6c. Use calculus to work out the maximum value of A as x varies. Calculus means differentiation. And maximum, I know I have a maximum when my differential is equal to 0. So the first thing I'm going to do is differentiate, and it's actually going to be dA by dx. So I've got this 80x minus 16x squared. If I differentiate, that's going to become 80 minus 32x. I'm going to set that equal to 0 and solve for x. So 2x dividing by 32 gives me 2.5. The question was asking for A though, not for x, so now I need to sub that into my area formula. So the area is 80 lots of 2.5 minus 16 lots of 2.5 squared. Gives me 100. You would get 1 mark for differentiating and setting it equal to 0, 1 mark for getting x is 2.5, 4 marks for 100 as your final answer. Question 7. Rearrange this to make D the subject. First thing I'm going to do is square on both sides, so c squared is d plus 4 over 3d, then multiply through by 3d, so 3c squared d is d plus 4. I want to make d the subject, so I'm going to get stuff with d on one side, stuff without d on the other, so I'm going to get rid of that d and get all my stuff with d on the left, 3c squared d minus d, and all my stuff without d on the right. I now need to factorise to get d in one place, so 3c squared minus 1, and then divide through by that factor. So d is equal to 4 over 3c squared minus 1. You'd get 1 mark for squaring, that's your first step. 1 mark for getting your d's onto one side, so up to here. 1 mark for sorry, that's your third mark. 1 mark for squaring, 1 mark for getting up to this line, 1 mark for getting your d's onto one side, and then full marks for d is 4 over 3c squared minus 1. Be careful, if you haven't written your d, if you've just written 4 over 3 squared minus 3c squared minus 1, you will lose a mark. For a formula, you have to have the d equals bit to get that fourth and final mark. 8a, factorise fully. I can see I've got these two things. I'm going to focus on the thing outside, and I can see the highest common factor of 2 and 8 is 2. So I'm going to have a 2 outside. And then I can see they've both got this a plus 3 bracket, so I'm going to need an a plus 3 outside. And I can see I've got a plus 3 to the 9, a plus 3 to the 8, so the highest common factor of those two things is a plus 3 to the 8. I'm now going to think, what would I need to have here? So when I multiply, I get 2a plus 3 to the 9. Well, I just need another a plus 3. I can put it in brackets, but I don't need to. And I'm going to think, what would I need to have here? So when I multiply, I get 8a plus 3 to the 8. Well, I'd need a 4. Bring down my operation. My final step is to just collect my 3 and my minus 4. So I'm going to have 2a plus 3 to the 8, a minus 1. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . you'd get 1 mark for any factorised expression. I'm just going to show those. So if you'd pulled out the 2 or an a plus 3 or a 2a plus 3 like squared or something, not to the power of 8, you'd get a mark. You'd get 1 mark for getting up to this line, and then full marks for the 3 and the -4 becoming a minus 1 and having this your final answer. 8b, factorise fully. I can see I've got a highest common factor of x to the 4, so I can pull that outside of a bracket, lots of x squared minus 9, and then this is the difference of 2 squares, so it's going to be x to the 4, x plus 3, x minus 3. You would get 1 mark for this, and full marks for this. 9. Quadrilateral ABCD is made from 2 triangles. Work out the area of ABCD. To find the area, I'm going to think of it as the area of 2 triangles. So the area of this triangle is just going to be a half times base and perpendicular height, because they've got a right angle there, so half times 7 times 5 gives me 17.5. And then for this triangle, I'm thinking angle sandwich, so I'm going to see if I can find this length. That's going to be the longest side of this right-angled triangle, so it's the square root of 5 squared plus 7 squared. Gives me root 74. So the area of this triangle is going to be a half times root 74 times 11 times sine 38. Gives me 29.128. And then I'm going to add together these two bits. Gives me 46.628. They haven't said a degree of accuracy, so I'll go to 3SF. It's going to be 46.6. They haven't. Oh no, they've given me the units. Don't need to worry about that. You would get 1 mark for half times 7 times 5. You would get 1 mark for square root of 5 squared plus 7 squared. 1 mark for half times root 74 times 11 sine 38. And then full marks for anything between 46.63 and 46.6. Question 10. Work out the value of d2y by dx squared when x is negative 2. So I need to differentiate. This term I want to write as something, lots of x to the something. So I'm going to rewrite this as 3x to the 4 minus, I'm going to write that as 6 times 1 over x, which is 6 times x to the negative 1. So I've got 3x to the 4 minus 6x to the negative 1. Now I'm ready to differentiate once. dy by dx is 12x cubed. Multiply by the old power, so it's going to become plus 6. Reduce the power by 1, x to the negative 2. Now I'm ready to differentiate again. d2y by dx squared is going to be 36x squared. Multiply by the old power, minus 12. Reduce the power by 1, x to the negative 3. I need to work out the value of that when x is negative 2, so now I'm going to sub in negative 2 for x. 36 lots of negative 2 squared minus 12 lots of negative 2 to the negative 3, and I can just type that into my calculator. Gives me 291 over 2, or 145.5. You would get 1 mark for 12x cubed or 6x to the negative 2. You would get 1 mark for 36x squared or negative 12x to the negative 3. 1 mark for both of those values, so if you have 36x squared and negative 12x to the negative 3, you'll get another mark. And then full marks for 145.5 or 291 over 2. Question 11. Triangle PQR is bounded by the line shown. Angle PQR is 90. Work out the x-coordinate of R. Okay, I can see these lines are 90 degrees, which is making me think about perpendicular lines. So the first thing I'm going to do is see if I can find the gradient of this line, which means I'm going to rearrange this to get it into the form y equals mx plus c. So 2y plus 3x equals 7. So 2y is, I'm going to write the x term first, so it's kind of in that form mx plus c. Divide by 2y, I'm going to write it as negative 3 over 2x plus 7 over 2. That means the gradient of this line is negative 3 over 2. Looks good, it's got a negative gradient, which means the gradient of this line is going to be positive 2/3. So m is positive 2/3. Now that I've got the gradient, I can find the equation of this line. Once I've got the equation, I can sub in y as 5 to get my x-coordinate of r. So m is 2/3, so y is 2/3 x plus c. I'm going to sub in 3, negative 1. Negative 1 is 2/3 lots of 3 plus c. Negative 1 is the 3's cancel, 2 plus c. So negative 3 is equal to c. That looks good. It's got a positive gradient, so I'm happy with the 2/3. And I can see it's going to intersect at a negative y coordinate, so I'm happy with negative 3. So y is 2/3 x, subtract 3. The next thing I'm going to do is substitute in, they want the x coordinate. I know that y is 5 at this point. So 5 is going to equal, replacing y with 5, 2/3 x minus 3, and making x the subject. So 8 is 2/3 x times by 3, 24 is 2x divided by 2, 12 is equal to x. You would get 1 mark for working out the gradient is negative 3 over 2. 1 mark for finding the gradient is 2/3. 1 mark for substituting in your point to get c is negative 3. 1 mark for replacing y with 5. And full marks for 12 as your final answer. 12a, use factor theorem to show 2x plus 1 is a factor of this. Factor theorem means I'll get 0 marks if I use polynomial long division. Factor theorem means I need to show that f of 1/2 is equal to 0. To do that, I'm going to do 4 lots of 1/2 cubed plus 28 lots of 1/2 squared plus 21 lots of 1/2 minus 18. I'm going to show for 2 marks I'd get 1 mark for this. For the next mark, I can't just say it's equal to 0. I need to show kind of one extra step. So I'm going to say that's 4 times 1/8 plus 28 times 1/4 plus, let's call that 21 over 2 minus 18. At this point, it would be enough to make it equal to 0, but I'm going to just sub that into my calculator to just double check. 4 times 1 over 8 plus 28 times 1 over 4 plus 21 over 2 minus 18. Let's double check. Brilliant, we get 0, which is equal to 0. You would get 1 mark for showing the half substituted into the function, and then full marks for an extra step, e.g. this, and making it equal to 0, showing it's equal to 0. That's an accuracy mark. You must have that equals 0. 13. Integers are made using some or all of these digits. Each integer must be greater than 50,000. No digits repeated. How many integers can be made? This is a product rule for counting question. I can see I've got 6 digits, but a number greater than 50,000 could be 5 digits or 6 digits. There's going to be a few options for this. I'm going to start with the 5-digit numbers. For the 5-digit numbers, this digit would have to be 5 or 6. So I've got 5 or 6 for that digit, so 2 options. And then the rest of the digits, it doesn't matter about them. So I'll have, if I've got used a 5 or a 6, I'll have 1 less number. I'll have 5 digits to pick from for my next digit. then 4, then 3, then 2. Multiplying them together gives me 240. For my 6-digit options, 1, 2, 3, 4, 5, 6, any 6-digit number will be bigger than 50,000, even if it started with a 1. Any 6-digit number, even if it starts with a 1, will be bigger than 50,000. The smallest 6-digit number is 100,000, which is bigger than 50,000. So I can have any digit here. So I'm going to say I've got 6 options for my first, then 5, then 4, then 3, then 2, then 1. Multiplying them together, I get 720. And then I'm going to add those together. Gives me 960. You would get 1 mark for each of these and full marks for 960 as your final answer. 14. The coefficient of x squared in the expansion of this is 150. Work out the 2 possible values of a. This is a binomial expansion or Pascal's triangle question, so I'm going to go up to the 4th row of Pascal's triangle. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. And set up my table, my Pascal's triangle number, my 3, and my ax. I just need to do the x squared, so I'm not going to fill in my whole table, but I'm going to start with my Pascal's triangle number 1, 4, 6, 4, 1. My 3's are going to go 3 to the 4, 3 to the 3, 3 squared, 3 to the 1, 3 to the 0. My ax goes ax, put it in brackets, to the 0, ax in brackets to the 1, ax in brackets squared. I'm going to stop there because I've got up to my x squared. So this is the column I'm going to focus on. I need to multiply all those bits together. So 6 times 3 squared times ax all squared is going to be 6 times 9 times a squared x squared is 6 times 9, 54 a squared x squared. So the coefficient is equal to 150, so 54a squared equals 150. And I'm going to solve to get a. So a squared is 150 divided by 54, 25 over 9. So the square root of that, a is going to be plus or minus 5/3. So a is 5/3, a is negative 5/3 are my 2 solutions. You would get 1 mark for this line, 6 times 3 squared times ax all squared. 1 mark for equating a squared to getting up to 150 over 54, so getting up to this, and then full marks for 5/3 and negative 5/3. Question 15. ABCDEF is a triangular prism with a right-angled triangle as a cross-section. ABCD, ABEF are rectangles. Angle BEF is 70, EF is 12, FC is 10. Work out the size of angle FBC. FBC, I can see, is this angle. So that's the angle they've asked me for. It's already got the triangle drawn that it's part of, so they've done that hardest step, which is often the drawing of the triangle. So I'm going to try and find this angle. I can see it's part of a right-angled triangle. So I've got this side. So I'm thinking of SOHCAHTOA. If I could find one other side, I'd have enough information to find this angle. So I'm thinking about other sides I could find. And which side could we find? We could find this side because AEFB is a rectangle, means all of the angles in this face are 90 degrees. So this, even though it doesn't really look at it if you look at it from this angle, this is a 90-degree angle because it's part of a rectangle. So this is a right-angled triangle. I'm going to draw triangle EFB out to one side so I can see it more clearly as if I'm looking facing down on it. So F, label my vertices E, B. I know that this is 12. I know that this is 70. So I could work out this side, BF, and then I would have another side, a second side in my FCB triangle. So I'm going to find this side using, I've got adjacent and opposite, so using TOA. So tan 70 is x over 12, timesing 3 by 12, 12 tan 70 gives me 32.969. Now I'm ready to find angle theta. I'm going to draw out this triangle FCB. Label my vertices, FCB. I've just worked out that FB is 32.969, and I know that FC is 10. I'm trying to find this angle. I've got my opposite and my hypotenuse, so that is so I'm going to use sine. Sine theta is 10 over 32.969. So theta is sine to the minus 1 of 10 over 32.969. Inverse sine of 10 divided by arcs gives me 17.656. They haven't said to what degree of accuracy. With angles, usually to 1 dp is good, which is also 3SF in this case, so that's going to be 17.7 degrees. You would get 1 mark for getting up to this, tan 70 is x over 12, 1 mark for 12 times tan 70, 1 mark for sine theta is 10 over the found value for FB, and then full marks for anything between 17.63 and 17.7. If you'd written 18 but had your unrounded answer somewhere, you'd get full marks. (16) hx is this. Solve 3hx equals h of 2x. 3hx is going to just be 3 lots of h of x, so 3 times 5x, x minus 4, equals h of 2x means I'm going to replace any x's in h of x with a 2x. So 5 lots of 2x, lots of 2x minus 4. I'm going to expand 15x, x minus 4 is 10x, lots of 2x minus 4. 15x squared minus 60x is 20x squared minus 40x. Get my x squared, so we'll actually get everything onto one side, make it equal to 0 because it's a quadratic. 5x squared, adding 60x plus 20x. I can divide 3 by 5, so 0 is x squared plus 4x. And then I'm not dividing by x. If I do that, I'll lose a solution. I'm factorising out an x. X plus 4 means either x is 0 or x is negative 4. 2 solutions. You would get 1 mark for 15x, x minus 4. 1 mark for 10x, 2x minus 4. 1 mark for getting up to this line where you've expanded. Full marks for x is 0, x is minus 4. 17. Solve the simultaneous equations. Don't use trial and improvement. You can see I've got a non-linear and a linear. So I'm going to use substitution. I'm going to make one of my variables the subject of my linear equation. It makes sense to make x the subject so that everything is positive. So x equals y plus 2. Now I'm going to substitute this for all of my x's. 10 lots of y plus 2 squared plus 5 lots of y plus 2 times y minus 7. That stays the same, sorry, 7y squared plus 23 equals 0. So 10 lots of y plus 2 times y plus 2 plus 5y times y plus 2 minus 7y squared plus 23 equals 0. 10 lots of y squared plus 4y plus 4 plus 5y squared plus 10y, 7y squared plus 23. 10y squared plus 40y plus 40. I'm going to collect these y squareds. 5y squared minus 7y squared is going to be minus 2y squared plus 10y plus 23 equals 0. Collect my y squareds. 10y squared minus 2y squared is going to give me 8y squared. 40y plus 10y is plus 50y. 40 plus 23 is plus 63 is equal to 0. At this stage I can use the formula. So I've got a, b and c, so sorry, not y, not x, y is going to be minus 50 plus minus the square root of 50 squared minus 4 lots of 8 lots of 63 all over 2 lots of 8. Plug that into my calculator. And I get negative 7 over 4. And negative 9 over 2. And I need to find my x values. Y is, x is y plus 2. So to get my x value, I'm just going to add 2, and I get negative, let's leave it as a fraction, x is negative 5 over 2, and for this one, I'm going to over 4 plus 2, positive a quarter, as my two sets of solutions. You would get 1 mark for substituting in to get an equation in one unknown, 1 mark for expanding and getting up to this line with no brackets, basically everything expanded, 1 mark for solving, so either formula or if you've factorised you'll get 4y plus 7, 2y plus 9. And then 1 mark for either both y coordinates or both x coordinates or one pair of xy, one pair of xy, full marks for both pairs of xy's. 16. The points A and B lie on this curve. Find A and B. I'm going to substitute in my x and y to my equation. So I'm going to start with this point. So I'm going to have negative 4 equals ab to the negative 1. And then this point, so negative 4/3 equals ab to the negative 2. I've got simultaneous equations, but for this type of pair of simultaneous equations, I'm going to use division to eliminate a variable. So what I'm going to do is call this equation 1 and this equation 2. And I'm going to do equation 1 divided by equation 2. So negative 4 divided by negative 4/3 gives me positive 3. My a's will cancel, and then I'm just going to write the b's to one side so I don't make a mistake. B to the negative 1 divided by b to the negative 2. I know that I subtract when I divide, so I'm going to subtract negative 2. That means I'm going to have b to the negative 1 plus 2. That means I'm going to have b to the 1. B to the 1, which is just b. So I've got my b value. 3 is equal to b. And then I can sub back in to find a. Let's go with equation 1. So negative 4 is equal to a times b to the negative 1. So negative 4 is equal to a times 3 to the negative 1. Negative 4 is equal to a times 3 to the negative 1 is 1/3. To get rid of a third, I'm going to times by 3 on both sides. So negative 12 is equal to a. You would get 1 mark for either of these equations and 2 marks for both of these equations, and then 1 mark for each of A and B. 19. Show this can be written in this form, where k is an integer. This makes me think of trig identities. In particular, sine squared plus cos squared is 1. So I'm going to make a note of that. Sine squared theta plus cos squared theta is identical to 1. I'm going to rewrite this in terms of s and c. So I'm going to write it as s cubed plus c minus c cubed all over s plus c. And I'm going to think about writing that c cubed, because I noticed there's no cos here, it's in terms of sine. So I'm going to think about trying to work with that with that cos cubed and get it maybe in terms of like a sine cubed or something. I know how to go from a sine squared or a cos squared to either cos squared to sine squared or sine squared to cos squared. I don't really know for sine cubed or cos cubed, but what I could do is I could say that cos cubed is equal to cos times cos squared. And then I know how to go from a cos squared to a sine squared. Remember, I'm trying to kind of move towards this, so get things in terms of sines instead of coses. So I'm going to rewrite my cos squared as, that's 1 minus sine squared, 1 minus sine squared. And multiply that out, so that's going to be cos minus cos sine squared. I've still got some coses, but let's just see what happens with this. So I'm going to replace that cos cubed with my cos minus cos sine squared and see how that looks. So I've got sine cubed plus cos minus cos sine squared all over sine plus cos. I'm going to expand that negative bracket, so sine cubed plus cos minus cos plus cos sine squared all over sine plus cos. Oh, that's quite nice. My coses that were just coses on their own cancel. So I'm left with sine cubed plus cos sine squared over sine plus cos. From here, I noticed that with this, there's no fraction, there's no sine. So I think that sine plus cos ended up getting cancelled, which makes me think I must have factorised the numerator and had a sine plus cos in my numerator. So I'm going to see if I can end up with a sine plus cos in my numerator, so that sine plus cos in the denominator can cancel. Let's see, if I had a sine plus cos, well, that cos must be that cos. So let's see if I factorise out and sine squared. Is that going to work? Multiply out, that'll get me sine cubed, and that'll get me, oh yeah, that'll get me a cos sine squared, so that works. My sine plus coses can then cancel, and I'm just left with sine squared. So my final answer is going to be sine squared x. I'm going to put it back as not s, but sine squared x. You would get 1 mark for rewriting your cos cubed as cos times 1 minus sine squared. You would get 1 mark for getting up to this stage where you've factorised out a sine squared and got the sine plus cos. And then full marks for sine squared x as your final answer.